Icing. Structural icing can occur when two key conditions are met. The aircraft is flying through visible moisture. The temperature is at or below freezing. Ice pellets form when rain droplets freeze at a higher altitude, often indicating freezing rain above. When you see heavy, wet snow, it means the temperature is just above freezing at your altitude. This type of snow has formed higher up, but is close to melting. Frost on an aircraft's wings disrupts airflow, which can cause early separation of the airflow, leading to a loss of lift. Frost should always be removed before flight. Even small patches of ice or frost can cause uneven stalls on the wing, leading to control issues during takeoff. Studies show that ice, snow, or frost as rough and thin medium or coarse sandpaper on the leading edge or upper surface of a wing can reduce lift by up to 30% and increase drag by 40%. Ice on the upper surface of the wing is harder to remove than ice on the leading edge, and smooth ice on top can be more dangerous than heavy ice on the leading edge. To determine the freezing level, you can use the standard temperature lapse rate of 2 degrees Celsius per 1,000 feet. For example, if the temperature is plus 8 degrees Celsius at 1,350 feet MSL, the freezing level is 4,000 feet above, or 5,350 feet MSL. When conditions are favorable for ice formation, check the airframe for ice before flight by using a flashlight to see light reflections off the surface. Ice on the wing is almost invisible but can significantly reduce lift. Narrow objects, such as the air temperature probe or pitot tube, are more likely to show visible ice first. The tailplane is particularly susceptible to icing because of its shape and position. A tailplane stall due to icing is most likely during flap extension on approach and landing. Warning signs of tailplane icing include elevator control pulsing or vibrations, an unexpected nose-down trim change, other unusual pitch behaviors, control pulsing or vibrations, reduced elevator effectiveness, a sudden nose-down pitch. To recover from a tailplane stall, retract the flaps to a safe position and increase power as needed to compensate for the loss of lift. Be careful not to over-increase power as it can worsen the stall in some aircraft. Uncommanded roll can also occur due to ice accumulation ahead of the ailerons. If this happens, lower the angle of attack by reducing pitch and, if in a turn, level the wings. Set appropriate power and monitor airspeed and angle of attack. Controlled descent is better than an uncontrolled one. If flaps are extended, do not retract them unless you're sure the upper wing surface is clear of ice, as retracting flaps increases the angle of attack at a given airspeed. Verify that wing ice protection is functioning properly on both sides. If you detect ice accumulation during flight and your aircraft does not have de-icing equipment, leave the area of precipitation or climb to an altitude where the temperature is above freezing. Remember that warmer air may not always be lower. In a temperature inversion, warmer air can be found at higher altitudes. For aircraft with pneumatic de-icing systems, it's best to activate the system as soon as you notice icing, rather than waiting for ice to build up. De-icing boots clear ice, but often leave a small amount behind, especially as airspeed or temperature decreases. In such conditions, it may take several cycles to clear the ice. Freezing rain can cause the most significant accumulation of structural ice. It indicates that temperatures above freezing exist at higher altitudes. Pilots should also be aware of supercooled large droplets, SLDs, which can form even when not visible at the surface. These droplets create clear, glossy ice on the aircraft. When flying in SLD conditions, look for irregular ice formations or pieces of ice shedding off the aircraft. It's essential to stay vigilant for SLD ice when flying through areas reporting precipitation, especially near freezing temperatures. SLD can occur aloft even when not observed at the surface. Pilots may choose to hand fly the aircraft periodically in icing conditions to monitor control feedback. If using the autopilot, pay close attention to abnormal trim changes or attitude adjustments. As ice builds up, the autopilot may continue trying to hold altitude, potentially leading to a stall if airspeed drops too low.